Afternoon and welcome to this short video on how to solve one of the past paper questions from the RQF Unit 1. So what we've got here is we've got a diagram showing a simply supported beam in static equilibrium. Okay, so it means equilibrium, this beam is not moving. We're going to calculate the support reactions at A and B. Okay, so we've got point A and point B. Now we know from our sessions that we've been doing is we've got forces coming down in a vertical direction here, which is the force at 50 and this UDL force. What that means is the force at A and the force at B must equal these ones that are coming down on top. Alright, otherwise this beam is going to move, which is not good. Alright, so we're going to work out how big this force is at A and how big this force is at B using our principle of moments. Okay, so we've got moments are equal to force times distance. Okay, so we've got force here and we've got a force here. Now, how big are those forces? It's quite straightforward. The force that we've got for point load, we'll call that F1, is equal to 50 newtons. But slightly trickier is the UDL force. Now, if it's 20 newtons per metre and it's spread over a distance of 5 metres, then this force, and we'll call this F2, must equal 20 newtons per metre times 5 because it's spread over the whole beam. Okay, so if the beam was 4 metres long, it'd be 20 times 4. If the beam was 10 metres long, it'd be 20 times 10. But in this case, it's 20 times 5. Okay, so what we're going to do is going to work out the sum of the forces that are acting on the top of this beam, and they equal the force at 1 plus the force at 2. Okay, so the sum of the forces are equal to 50 from F1 plus the force at 2, which is a value of 20 times 5, which is 100. Okay, so the sum of the forces is equal to 150 newtons. Now, that tells us that A and B must equal 150 newtons, otherwise this beam isn't going to be in equilibrium. Okay, so how do we find out how much of this 150 is at A and how much of it is at B? Then we're going to go back to our moments calculation here. Alright, now as I've mentioned a million times before, this formula is useless unless you know what M means, and unless you know what F means, and then you know what S means. Alright, so we're going to make it slightly trickier to comprehend even further by calling this F here, I'm going to call that B. Alright, so we've got the moments are going to be equal, the moments at B are going to be equal to whatever the value force is at B times the distance at B. Now how far is the distance from B from A? Alright, now it just so happens that A is at the same point at the end of the beam here, and we'll call that the pivot. Okay, so the distance that we need in this case is 5 metres. So B, we don't know where that is yet, but we do know the distance. So B times 5. And that's going to equal the sum of the forces that are coming down from the top of the beam, which again are found using our moments calculation, force times distance. So what force have we got for force number 1? It's 50. What distance have we got now? That's the distance from our pivot that we've got here. So pivot, the distance to that point load is 2 metres times 2. I'm going to pop some brackets on that. I'm going to add the force for the UDL. Now we know it's 100 because it's 20 per metre over 5 metres, but what distance are we going to use? Now we remember from our previous sessions is the distance for turning a UDL into a point load is exactly half the distance of the spread of the UDL. So in this case it's going to be half of 5. We'll do 5 divided by 2. Okay, so what we're going to have here is going to be B times 5 is going to be equal to 100 plus 250, which is equal to 350. Okay, so next bit we're going to divide both of this by 5, divide that by 5, divide that by 5, and then what we get here is we've got B is equal to 350 divided by 5, which is 70 newtons. Okay, and we'll pop that up here just so we can make it a little bit clearer. So B is equal to 70 newtons. So what is A though? Okay, if we say the sum of the forces is 150, the sum of the forces equal 150. What that means is that the sum of the forces are equal to B in whatever the distance, the dimension of A is. So nice and simple, A is going to equal the sum of the forces minus B, which is equal to 150 minus B, which is 70. So A is going to equal 80 newtons. Alright, now if I pop that on my answer sheet, I'm pretty sure the person who's marking it would find it, but just so that they know, to keep it nice and neat, I'm going to do A equals 80 newtons, B equals 70 newtons. One last check, do these both add up to 150, 80 plus 70? Yeah, and if they don't, I've gone wrong somewhere. So that's how to solve the simply supported beam questions that are quite common in your RQF exam. So have a practice of the ones in your workbook, and if you've got any problems, let me know.